Hi everyone. Today I'm gonna walk through this circuit problem. So first I drew a little sketch of our circuit right here. And so we have a battery at the bottom, and then we have the wires that split up into two different paths. And so one path goes to R1, and then the other path goes through resistor R2. And so because the circuit is like splits like this, it means the resistors are in parallel. So, before we do any math, let's look at the variables we're going to be working with. So, we have V, which stands for voltage, and it is also called the potential difference. And it's basically the electrical push in the circuit. And its SI unit is in volts. Oh. Next, we have I1 and I2. And so I stands for the current, which is just how fast the electricity is flowing through the wires. And its SI unit is just amperes. And so I1 is the current going through the going first resistor, and its unit is in amperes. And I2 is the current going through the second resistor. And it's also in amperes. And so finally we have R1 and R2. So R1, or well, first of all, the resistance is like how much a component fights against the flow of electricity. And so the SI unit for resistance is in ohms, which we could write with a Greek omega signal, and R1 is just the resistance of the first resistor in ohms, and then R2 is the resistance of the second in also in ohms. And so
Motion detected at the doorbell.
the big rule we need to use here is Ohm's law. And so the Saturn equation is voltage is equal to current times the resistance. So V equals I times R. And but since the question is asking us about the ratio of the currents, um we need to rearrange this to solve for I. So we could do I is equal to V over R. So that the current is equal to the voltage times the resistance. And now here is the trick with the parallel circuits. Because both of these resistors are directly connected to the same battery paths, they both experience exact same voltage. And so the voltage doesn't split up. It stays the same for both branches. And so the first resistor, the current is I1 is equal to V over R1. And for the second resistor, it's I2 is equal to V over R2. And so the problem just wants us to find the ratio of I1 over I2. So we just literally just put our two equations on top of each other like a giant fraction. So it would be like I1 over I2 is equal to V over R1 over V over R2. And so we get I1 over I2 is equal to V over R1 divided by V over R2. And so this kind of looks messy with the fractions inside of fractions, so we could fix it. So we can use that math trick where basically like you multiply by the reciprocal. So basically we keep the top fraction the same and multiply it by the top bottom fraction flipped upside down. And so if you do that, you would get I1 over I2 is equal to V over R1 times R2 over V. And this is the math trick. And so now you could see that there is a V on the top and a V on the bottom. And so they can just cancel each other out completely. And so what we're left is just I over I2 is equal to um R2 over R1 because the V's cancel each other out. R2 over R1. And so the final answer is the first option on the page. The ratios of the currents is equal to R2 over R1. And so it makes sense because the current and the resistance are inversely related. So more resistance means less circuit, and that's it. Thank you for watching.